So now let's say the second question. So first of all, let's say what we need to do. Given fxy equals to 1 over a y squared x, y is larger than 1 and x, we have x is larger than 1 over y, smaller than y. So the first question is that we need to draw the non-zero definition region of f. And the second question is that find a so that fxy is a valid joint density function. And the third question is find a draw the marginal density functions fx and fy, and for verify fx and fy are valid density functions. Yeah, so now let's see the answer. So we can draw fxy as the given formula. Fxy equals to 1 over ay squared x, and y is larger and greater than equal to 1, and x is larger than 1 over y, smaller than y. We can get a draw of this formula. So that's the first question, and we can say the second question. Fxy equals 1 over ay squared x, and that's equal to the sum from 1 to the limit, the positive eliminate the sum of 1 over y to y, and 1 over a y squared x dx dy, and that's equal to the sum of 1 to positive eliminate 1 over a y squared, and the sum of 1 over y to y, 1 over x dx dy. And we do some calculation. After 7 steps, we can get an answer. We can get a equals to 2. Also, we can use the formula sum x n log x dx equals to x plus 1 over n plus 1 square with the n plus 1 log x minus 1 plus a. That's another formula we can use. Yeah, that's the second part. And for the third and fourth question, we can solve them together. We know the formula fy equals to the sum of negative eliminate to positive eliminate fxy dx. We know that we can do some calculate, and finally we know that that's equals to log y over y squared, where y is is greater and equal to 1 and smaller than positive eliminate, and also 0 otherwise. So we can get the sum of 1 to positive eliminate log y over y squared dy equals to 1. Yes, fy is a valid probability density function, and also we know that fx equals to the negative eliminate to positive eliminate fx xy dy, and finally we can get it yeah. Also we can get fx is a valid probability density function.